Alright, let's take a look at a particularly tricky word problem. It's tricky because of the fact that to develop the quadratic equation, you have to consider a constraint, and it's a geometric problem, which often throws us off. The question is, and I'll underline important information as I read, a right triangle, there's important information, has a perimeter of 3 meters, and a hypotenuse which is 130 centimeters long. We need to calculate the lengths of the other two arms of the triangle. Well, my first step for any problem like this is going to be to make a diagram. So there we go. I'll draw a right triangle. Remember, a right triangle is always indicated by the little box in the bottom corner. So, I've labeled the sides of my triangle. It's always important to label anything that you know. And if you know that there are equal lengths, you should probably use the same variable. I've got 3 sides that are all of different lengths, and one that is given by the 130 centimeters long. Once I have this information recorded, I should probably make a statement to let you know what my variables are. Let's let A, B, and C represent the sides of the triangle as indicated below. Now I'm going to use the first piece of information, my perimeter of 3 meters, to make a formula about A, B, and C. So I know that A plus B plus C is equal to 3 meters. But I'm going to write it as 300 centimeters. Next, I know that C is equal to 130 centimeters. So I'm actually going to substitute that value in. So on my next line I'll write A plus B plus 130 centimeters is equal to 300 centimeters. Pardon my ugly writing. I'm going to simplify this a bit. So I'll have A plus B is equal to 170 centimeters. And all I did here to simplify was I subtracted my 130 centimeters to bring it over to the other side. So there we go. I've got one equation involving the 2 variables that I'm looking for. Keep in mind, I'm looking for the length A and the length B. Alright. Another way that I can relate these variables, A, B, and C, is using the Pythagorean theorem. Whenever you see a right triangle question, chances are the Pythagorean theorem is going to be useful. So I'll write the relationship. A squared plus B squared is equal to C squared. And I'll fill in some of the information that I know. A squared plus B squared is equal to 130 squared. I'm going to simplify this a bit as well. A squared plus B squared is equal to 16,900. Now I'm in a position where I want to be. I have a quadratic, and I also have a term that's going to allow me to solve. This other term here, this A plus B is equal to 170, is going to be what I would call my constraint. I'll solve in my constraint for one of the variables, and it doesn't matter which one I choose. So I'm going to choose to solve for B. I'll solve for B by subtracting A from both sides. And I'll have B is equal to 170 minus A. I now have a value of B. I can substitute this value into my quadratic. And then I'll have a quadratic that only has A and A for the variables. So let's go ahead and see that done. So I'm going to substitute B into my quadratic. I'll make a little note just to let my teacher know what I'm doing. Sub B is equal to 170 minus a into a squared plus b squared is equal to 16,900. When I do this, I get a squared plus, and instead of b, I'm going to write 170 minus a squared, because the original term b was squared, is equal to 1690. Rather, 16,900. Now I need to expand this and get it into standard form. My goal here is always to get my quadratic into standard form so I can find the roots. So I'll have a squared plus 170 times 170. Ooh. I might have to get the calculator on that one. Although, okay, it's 289, sorry, 28,900 minus 170a minus 170a, and then negative a times negative a would be positive a squared. And this is all equal to 16,900. From here, I've got to collect like terms. So I'll do that. I've got two terms which contain a squared, two terms which just contain a, and two other terms which contain no variable. I'm going to collect everything on the right side of this equation. To do that, I'll have to bring the 1690 over by subtracting it. So a squareds, I've got 2a squared minus 340a, and then this will be plus what looks like 12,000 is equal to 0. From here I can choose to do a couple of things. I can choose to factor immediately, I can divide by a common factor of 2, or I can go straight to the quadratic formula. I'm going to divide by a common factor of 2. As I do that, I have to do that to each term, including the 0 on the other side. That leaves me with a squared minus 170 a plus 6,000 is equal to 0. I'm now looking for factors of a. It's a simple trinomial, so I know it's going to end up having this form. The first sign is negative, and the second sign is positive, so I know both the signs are the same. I now need to find two numbers that multiply to get 6,000 and add to get 170. My numbers are going to be 150 and 20, which means that the roots are 150 and 20. Now, let's have a look at what our roots represented. Our roots represented the possible lengths of the line segment A. So, knowing that it's 150 or 20 means that one arm, A, is 150 centimeters. Why did I rule out 20? 20 is a factor. Well, you're going to see shortly that, remember, A plus B plus C equaled 300. Now if we substitute our value of A in, we'll have 150 plus B plus, remember C was 130, is equal to 300. We'll then have B plus 280 is equal to 300. And now notice, as we subtract 280, we'll find that B is equal to 20. So the other arm B is 20 centimeters. Both of our solutions for A